Welcome back to the morning show. And hey, it's Monday, so we've got another Wise Guys segment. Paul, what are we talking about today?
So today, we're talking about how to make something warm by freezing it, which sounds totally crazy, right?
Totally opposite.
Yeah, so, okay, we're going to start out in a strange place. We're going to start out with salt, normal table salt. So salt is sodium chloride, and I've got this sodium ion here and this sodium chloride. Sodium ion positive, chlorine ion negative, and they're attracted to each other, they're stuck together, and to pull them apart, you have to put energy in. So whenever salt dissolves, you have to put energy in to have that happen. And I have here just a little thing of water with a thermometer going into it, and maybe we can just look and see what the temperature on that thermometer is. If we just zoom into this. Awesome, great, 73 degrees. And I'm just going to put a bunch of salt in this water right now. Boom, and just do a quick little stir here. And we're going to see, I think, that the temperature of the water will now be lower if we just go back to the temperature. Great, so it's definitely lower. It was 73 and now it's dropping.
Already, by
yeah, so the energy is coming from the water to pull these things apart. Okay, so you might ask though, well, why do you want to pull these things apart? Because wouldn't they prefer to have the lowest possible energy by being stuck together? And so the question is, why does anything ever dissolve, for example? Okay, so to answer that, we have to do another demo. So I have here just a bunch of quarters that are all stacked up. They're all heads at the moment facing up. And if I just put them in the container, you'll see that in the end, we got like half heads, half tails. It's mixed.
Randomized,
right, it gets randomized. And why does that happen? That has to do because we're trying to maximize the entropy. So if we go to our first slide here, the entropy is the number of ways that you could configure something that will distribute particles or energy or coins being flipped. And you always want to have the maximum amount of entropy because that's the thing that's most likely to happen because there's the most number of ways. So for example, with the coins, there's kind of only two ways to have them be all the same. They're either all heads or all tails. But if I allow them be roughly half and half, then there's a lot more ways that can happen.
Okay.
Okay, so if we come back to the salt example, just come back to me. So there are when the salt molecules are together and they're in the water, that one molecule has, all these different places in the water it could be. But if instead I split it into two pieces, now each of those pieces have all those different ways. So there's a lot more ways, and so you're going to increase the entropy by pulling things apart. But there's a cost because you've had to take energy out of the environment to do that. So you've reduced the entropy of the environment a little bit. Apparently because the thing dissolves, not as much as you've increased the entropy by having the thing dissolve. But that depends on the temperature. And the lower the temperature is, the bigger a little bit of energy will change the entropy. And so at lower temperatures, the energy from the environment is going to make a bigger deal on its entropy. Basically what that means is that at low temperatures, things are going to want to be solids. And that's, the threshold is going to be the freezing temperature, the freezing point. Okay, so next up, last slide here is the sodium acetate, which is the next thing we're going to look at, which is another kind of like salt. It's got sodium and this other acetic acid, and those are attracted to each other. To pull them apart, it takes energy. Okay, so now we come back to us, and I have here this packet which is filled with sodium acetate, and you notice it's a liquid. The freezing point for sodium acetate is something like 130 degrees Fahrenheit, which is not that hot in here. So then you're saying, well, how can it be a liquid? Well, this is what's called supercooled. So it wants to be a solid, but it doesn't know how to crystallize yet. It hadn't figured that out. And there's a little metal disc in here. When we flip this metal disc, what's going to happen? That's going to put a little shock wave. Some of the ions are going to get forced next to each other. They're going to be able to crystallize, and then all the ones next to them are going to crystallize all the ones next to them. And there's going to be a chain reaction. The whole thing is going to freeze. So let's just take a look at that because it's super cool. We might want to zoom in on this because it's like the most amazing thing. Okay, so I'm just going to start this here.
Popped it there.
And we got it, and we are now watching this whole thing is now suddenly freezing.
It's almost like a hand warmer effect.
It is, well, it is in fact a hand warmer. And if we look at the temperature now on the little thermometer that's right next to this, we'll see.
Already at 74.
We'll see that the temperature is going way, way up. In fact, it's going to go, if I can keep this in contact, it's going to go all the way up to the, it should go all the way up to the 130 degrees, yeah? So it'll get very, very warm. And we can look at this in kind of another fun way. So I have one of these.
Oh, it's already very,
very warm. So I have here my little thermal camera, and we can look at another one of these. So this is not set off yet, and I'm just going to set this off, and we can look at it hopefully on the camera. If I can get to the disc.
Here, you need some assistance. I can pop it there.
Okay, there we go. Okay, so now we can watch it, and we can see it's spreading out, right? The whole thing is suddenly freezing. it's freezing and it's getting very hot. And I know that that's very confusing. Why is it hot? But if you think about it at home, if you want to turn water into ice, what do you have to do? You have to take energy out of it, and that energy goes out the back of your freezer.
Yeah.
In this case, that energy goes into the molecular motion of these things, and it heats up.
Okay,
and
so
the
it's
great
pushing all that into
And the
that.
great thing is, just like at home, if you want to turn ice back into water, you can just put energy back in, and it's reversible. If you just put these into boiling water for about 5 minutes or something like that, they will re-liquefy, and then you can reuse them.
I was just going to say,
very
I
useful.
have very similar hand warmers.
Yes,
and
these
that's
are
exactly
hand
how that
warmers, and
works.
this is how they're working.
Wow, that's awesome.
All right.
Paul, thank you so much.
Thank you. Happy holidays.
Still to come on the morning show, Adam will have your forecast up next.